All right, welcome back. I hope you're having an amazing time so far. Our next speaker is David Talby. He is CTO at John Snow Labs. Please join me in welcoming David to our virtual stage.
Hello, everyone, and thank you for the introduction. My name is David Talby. I work at John Snow Labs on natural language processing in healthcare. And what I like to share with you today are some ways in which you can get state-of-the-art medical, so clinical and biomedical natural language processing with one line of Python code working today on your project. So just to introduce kind of who I am and why I'm here. John Snow Labs, my team is the team behind the Spark NLP library. Spark NLP is a software library with APIs for Python, Java, and Scala that's now it's in the 4th year of being the most popular NLP library in the enterprise, outside research, when people want to take software and AI systems into production. Specifically within the healthcare space, so within healthcare and life science, based on the last NLP industry survey by Gradient Flow, it has a 59% market share, meaning most data scientists are actually in industry building project for our domain, for healthcare and life science, choose to use Spark NLP for healthcare to get this done and be successful. And you can also see just the recent growth of the library. So it's now, I think, with around 1.5 million downloads per month, with a significant community behind the project, especially around data science and AI systems that actually make it to production. So let's talk a bit about what those different use cases are. So John Snow Labs also hosts the NLP Summit and the Healthcare NLP Summit, which is a community event that shows different open source projects, libraries, and applied use cases. And you can see some of the ways in which these are some of our customers who have put the software to good use. So use cases range from clinical decision support, matching patients to clinical trials, building real-world databases, especially in oncology, when you need to read pathology reports, radiology reports, sequencing reports, automated question answering, either on patient data or on clinical guidelines, building biomedical knowledge graph. So when you're reading biomedical research, PubMed, clinical trials, patents, internal documents, de-identifying documents, automatically discovering adverse drug events from both clinical data and social media data, and basically almost any use case that involves really understanding data that's clinical by nature or biomedical by nature requires use of strong NLP library, and a lot of the information that you really need and really care about when making those decisions is only available in free text. In order to get to do what I promised you, which is state-of-the-art NLP, healthcare NLP in one lines of code, we need two components. One of them is Spark NLP for healthcare. Spark NLP for healthcare is a software product we have that's built on top of the Spark NLP open source library. So it gives you, first of all the 4,000 plus pre-trained models, embeddings, languages, more than 200 languages that come with Spark NLP. Everything that you do natively scales to a cluster, either for training or for inference. It's optimized, and we're doing continuous work with Intel and NVIDIA to make sure it's optimized for the latest and greatest hardware platform. And of course, optimized for production deployment in terms of speed, in terms of security and privacy, and in terms of monitoring, logging everything you expect in a real production system. Specifically for healthcare, some of the key NLP tasks that are added are clinical name entity recognition, which we'll talk about, entity linking, so mapping entities to standard terminologies and doing this in context, assertion status detection, relation extraction, and de-identification. And in a few minutes, we'll talk a bit about why they are and how do you really get the best results with them. Everything we do, all of these models are deep learning, transfer learning models, and they're trainable and tunable as well. So if you have your own specific use case, for example, you're dealing with dentistry, you're dealing with ophthalmology, we have an annotation tool, and within the annotation tool, you can start with pre-trained models or embeddings. You can load your own documents and data, you can annotate them, and then using active learning and transfer learning, really very quickly have models that are high accuracy and tuned for your own use case. So that's one component, Spark NLP for healthcare. The other important component is the NMU library. And that's it's a fairly new open source library that we have. It's about 2 years old. So it is definitely in wide production use, but still improving. And the goal with the NLU library was to provide the community, the open source community, all of the power of Spark NLP, from the accuracy, scalability, range of models, production readiness, but specifically for the Python ecosystem with the simplicity of Python. And one big goal for the NLU library is that the vast majority of things you should be able to do with just one line of code. That does everything for you, from downloading, loading into memory, optimizing the models, the embeddings, the pipeline, memory usage, all of that, and then be able to run it on text, whether you're on single core, multi-core, doing threading, scaling, whatever may be the case, whatever the language, and just give you the results immediately. It's also very nicely integrated within the Python ecosystem. So, for example, we can look at a few code examples. You can just send it a string as the examples here show, but you can also just send it, a pandas data frame, and then what you get is a result is a pandas data frame. You can also just send it a array data frame or a Spark data frame, and that's what you get back. So it's super easy to integrate it kind of with the rest of the Python ecosystem, right? And if you have a project where you're doing some NLP work, you're getting features, and then you want to throw it into PyTorch or TensorFlow or just a different kind of ecosystem, really, there's just zero friction in doing that. You can see here some examples of NLU running on some of the open source Spark NLP models. So on the left, you can see 2 examples. One of them is name entity recognition. So Angela Merkel is from Germany, and what you'll get back is a pandas data frame, and 2 of the columns would be, you'll get Angela Merkel, who is a person, and Germany is location. So this is just using kind of the classic pre-trained NER, name entity recognition model in English. And that's available in quite a few languages, and also with quite a few pre-trained models, even just in English, if you're looking for restaurant data, financial data, legal data, and so forth. The second example is a document classification example. And there are hundreds of pre-trained text classification models that come with the library. The example here is fake news detection. So if you do nlu.load en.classify.fake news, so fake news classifier in English, predict unicorn sighted on Mars, you get the result. In this case, this is unfortunately fake news with the confidence of 1. You can also ask to get the embeddings or kind of other data that will help. On the right, you can see some other examples. So other things that the library can do is automated grammar correction. So we can correct he are moving here to he is moving here. We can change writing style. So we can change, for example, informal text like who gives a crap to kind of the more formal way, which is who cares. We can do question answering. Who is the president of Nigeria? You get the response. It's Buhari. And similarly, you have everything from dependency analysis, part of speech tagging, spell checking, sentiment and emotion classification, and translation, and all of this in quite a few languages. So what we'll see now is how we combine Spark NLP for healthcare and Spark NLU to really give you state-of-the-art accuracy. And just the one thing we do before we look at the code is really define what state-of-the-art means. It's not a marketing term, it's an actual academic term. And this is what we strive for, and how we measure ourselves and compare ourselves. So state-of-the-art is an academic term, which means that for some benchmark that other people have competed on, you are showing kind of the best, usually accuracy, right, by some metric, mostly in the machine learning and deep learning space. And you've written a paper, you have a peer-reviewed paper, you publish the code, it is reproducible. So with state-of-the-art, we're looking for cases where what we look to do is have peer-reviewed papers that show that we have delivered the best accuracy ever achieved on competitive academic benchmarks. Also, it's important that these are not benchmarks that we have built in the lab to match our own software. These are benchmarks that have been around for 3, 5, 10 years that dozens of research teams compete on and publish papers on. We release code and make it public with those benchmarks so that any other researchers can reproduce it, check our work, do better, right? Because that's, after all, that's how we make progress in academia. And another requirement is that we are looking for code that has multiple production deployments, because there's a big difference between an nice academic result and something that would actually work in production. So now let's look at some of the examples. And what you can see here is this is the one-liner in the NLU library, and here are the results. One first example is clinical name entity recognition. And the top example here is an example from radiology. You can see we have a radiology clinical model. You load it with NLU, and in this case, instead of doing .predict, you do .viz, which shows you this nice visualization directly within your Python notebook. And you can look at imaging findings, body parts, direction. At the bottom here, you can see another example for extracting drug information. As you can see, it's not just the drug name. We also extract things like dosage, frequency, strength, and route. Right, so if you're taking OxyContin, 30 milligrams PO Q12 hours, we know that 30 milligrams is the strength, PO is the route by mouth, and frequency is twice a day. And also, all of this, as you can see, it's one-liner to load everything that's involved in the pipeline. Then you can give me the text, and also this here we are just showing examples with single strings. It can work with, you can just give it a pandas data frame and get those results. Other popular clinical name entity recognition, and there's more than 150 entities that Spark NLP for healthcare can recognize right out of the box. But one interesting one is clinical risk factors, and in general, social determinants of health are interesting. In this case, you can see we extract things like obesity, diabetes, hypertension, and hyperlipidemia, which is often important when you're trying to build cohorts. And the example at the bottom is example for identify sensitive data. So one other thing the software does for you is the identification, especially of unstructured data, right, free text. And to do that, what you need is really high accuracy models that can identify, as you can see, a patient name, a doctor's name, hospital name, addresses, and then dates, codes, professions, and so forth. For name clinical entity recognition, one paper we've published in 2021, and that's also it's available in archive, available online, has achieved a new state-of-the-art accuracy for 3 main widely competitive academic benchmarks: the 2010 I2B2, 2014 N2C2 de-identification task, and 2018 N2C2 medication extraction, and also the code for that is on paper. The code is public, you can reproduce it. Another thing that we've seen in a more recent paper in 2021 is a comparison with AWS Medical Comprehend and the Google Cloud Healthcare API that shows us leading really by more than 10% in terms of F1 accuracy compared to what these services achieve for extracting medical problems, medical tests, and medical drugs out of free text. Beyond clinical name entity recognition, there's also a lot of interest and a lot of pre-trained models that we have on biomedical name entity recognition. So this is more on reading medical research papers, for example, or research reports. And you can see 2 examples here. One of them is around extracting genes and human phenotypes. So if you're trying to automatically read literature and understand, okay, these genes seem to be correlated to these bad things that can happen to people, as you can see, we extract that automatically. The lower examples show finding DNA and protein mutations, which is also of great interest. And similarly, you may want to extract species, viruses, specific gene variants, and so forth. And there are models for all of these. For biomedical name entity recognition, the paper that you have here from late 2020 shows that we've achieved new state-of-the-art accuracy for 7 out of 8 widely used biomedical benchmarks. And also, to reiterate, we are doing this in the context of a production-grade system, not just an academic result. And which, of course, as you can imagine, involves much more software engineering work to get that done. The next task I want to show, as you can see the one line of code right here. We just ask NLU to load the right model, and we run it through the text, and that's really all you need to do. You just pip install NLU, import the library, and do that. Is the assertion status detection, and with assertion status detection, beyond looking at name entities, we're also looking at did the thing actually happen, so we can differentiate between patient diagnosed with cancer, which is problem present, versus there is no sign of cancer, or a test indicate that patient might have cancer, so something is possible. We can also tell whether the patient's father has cancer, which is a family issue. So as you can see, just the word cancer and the fact you can recognize it does not really help. If you can't differentiate whether the patient has it, does not have it, or someone else has it. So that's a separate deep learning problem. On this specific problem, also in a recent paper we published last year, we've improved the state-of-the-art accuracy using Mimic3 data with kind of the most widely used benchmark for this specific example. The last kind of example I'd like to show as an example of what you can do is on relation extraction. Relation extraction looks at, as you can see with the visual example, also finding relationships between different entities that you recognize. So if there's numbness in the left hand, we want to connect the symptom to the body part and to the direction. In the lower examples here, you can see relationships between diagnosis or treatments and dates, which is super important when you have chronic patients. In other examples, you may want to do this. You may want to look at temporal relationships or relations between drugs and symptoms. So, did the drug help the infection, or did it not help, or am I avoiding it because I'm afraid of the side effects? And you may also want to extract relationships from biomedical data. Okay, so for example, automatically understanding drug-drug relationships by reading, for example, PubMed research. Relation extraction is one other case where we have the new peer-reviewed paper, and also what you can see, what you're seeing is direct screenshot from papers with code, showing that now we have state-of-the-art results for several of the most widely used relation extraction models in the biomedical domain, the clinical and biomedical domains. So those are just some of the examples. There are other cases where we'll be able to do this, like automated text classification for clinical text, automated adverse event detection, and question answering on clinical data. If you'd like to learn more, the Healthcare NLP Summit is coming up in early April. And more than that, if you go to nlp.johnsonlabs.com/demos, there are over 300 live demos with Streamlit apps and Colab demos that you can run yourself. So you can try it yourself, run it on your own data, seeing how easy it is to use and how accurate it performs on your own results. So with that, thank you very much, and best of luck and success with your own healthcare NLP projects.
Amazing, David. Thank you so much for sharing. If you could stop sharing your screen, I know this virtual audience wants to give you a huge virtual round of applause. Thank you again for sharing these insights with us today. And for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our awesome exhibits. Thanks so much, and we'll see you around.